Okay, I'm going to pull everything together today that we did yesterday, and then I'm going to let you go back to work on doing what you're doing. There's a couple things I want you to see. So I'm starting the question on asked. I'm going to start with it right now. Page 165, question 5. Now, it doesn't incorporate everything that I really wanted, what it's going to do for today. All right. There's a couple things that I want to point out. I pointed them out during the applied class, but you may or may not remember, so I'll point them out again today. Okay, when you're doing a trig graph, there is an infinite number of equations that can describe the same graph. And they don't necessarily all have to be sine graphs. They can be sine graphs and cos graphs and still explain the same graph that you just did. There's only one value that matters in that case, and that's the c value. The c value can change from graph to graph, which changes how we're presenting the graph. The a, the b, and the d will all stay consistent. They won't change. So let's look at page 165 right now. And the first thing I want you to do, and the first thing I would do, again, is find these values, right? And the value I always start with when I'm looking at a graph is the midline. So what's the midline of that graph?
1.
Plus 1? Okay. So everything's moved up 1. So from the midline, let's find the amplitude then. So what's the amplitude of that graph? 4. Okay. My b value. So there's numerous ways you can do this. I'm going to use the bottom of the graph to find out what my b value is. Now remember, period is equal to 2 pi over b, correct? Therefore, b is equal to 2 pi over my period. So I need to find out what my period is on this graph in order to find my b value. So I'm going to use the bottom of the graph, my minimum value. So where does my first minimum occur after 0 radians? At pi, right? And then where's my next one occur? 5 pi. So what does that make the 4 pi? That makes the period 4 pi. Which then makes my b value actually what? 1/2. Okay, so far? Alright, so now, those values do not change. Now, I need to make an equation. The first equation I'm going to make is using sine. The second equation I'm going to make is using cos. And then I'm going to find one of each. So here's how this works. I use my b, c, and d. Bless you. So I go 4 sine 1/2 x minus bracket plus 1. A is 4, b is 1/2, d is 1. Right? So now, when I'm using sine, I am looking for the first point on the graph, or a point on the graph that is on the midline and moving up and to the right. So what is that x value? 2 pi. 2 pi works. So therefore, my c value in this case is 2 pi. I've moved my graph 2 pi to the right. Okay? I'm going to do this again. It's usually easier to explain this using cos. Where does my first maximum value occur?
3.
In the positive, it would be what?
3 pi.
3 pi. Sure. So I can make that 3 pi. Now how am I getting that? Well, if I look at the graph of y equals sine theta, y equals sine theta, where does it start at? 0 and? Do this again. Y equals sine x, or sine theta. Where does it start at? 0 and? 0 and 0, right? Where does cos start at? At its maximum value, right? So there's my cos graph, like this, correct? So that's y equals cos x. So when I'm looking at my graph, I'm trying to find where those two coordinates begin, because that's how much my graph is shifted. You get that? So in this graph, I'm saying that my first spot, where right here, is at 2 pi. Yes?
Could that also, like, could you also take away that 2 pi?
Just wait. I'm gonna get to what you're about to ask. Okay? So here it is. So if I'm looking in the positive, the first spot that the graph goes from the midline and up to the right is at 2 pi. Would you all agree? Okay. Where's the next spot that it goes up and to the right? 6 pi. So another equation I could use, there's another equation. Exact same equation. How about cos? Give me the first maximum value you see on the graph. It doesn't have to be in the positive. Where's the first maximum value you see on the graph? At which? Negative pi. So my c value can be negative pi. You kind of catch on to what I'm doing here now?
Yeah.
Jake, does that answer the question?
Not what I was going to do.
Okay, so let me try one more, and I'll see if, I'm going to show you one more thing here. And then I'll go back and answer that question for you, okay? There is one more way I could have done this question. That's your question. At 0 and 1 on that graph, does it go down and to the right? At 0 and 1, does it go down to the right? So I could say then that I have actually just flipped my sine graph. And put a negative 4 there. That makes it flip over, right? That's also an equation that works. If you were to graph all of those equations, they would give you that exact same graph on 5a. Every one of them. Okay? Because your domain is an x is an element of all reals, right? As long as your amplitude, your period, and your midline stay the same, it doesn't matter where you start your equation. It's all the same equation. So I could start it at 2 pi. I could start it at 6 pi. But it still goes forever left and right. Negative infinity, positive infinity, right? I can change it to a cos equation. All of these equations are exactly the same equation. As long as A, B, and D don't change, I have the exact same equation. All C does is tell you where you're starting at when you describe that equation. Are we okay so far? Does everybody understand what I'm doing here? Who doesn't? Put up your hand. If you're still lost, On?
The last.
This guy?
Yeah.
Okay? Let me explain it using this. Okay? What if I rewrote this equation as y equals negative sine x? What does that negative do to the graph?
Make it.
Flips it. Like that. So it takes this green graph and it flips it upside down, right? Look at that graph right there. At 0 and 1, is it flipped? Does it start by going down? Perfect. Good stuff.
Thank you.
Oh, sorry. Yeah, no problem. Anybody else not sure of what we did there? Okay. Don't make eye contact. I might ask you something. All right. Let's try B now. Okay. So the first thing that you're going to do is this: A, B, C, D. What's the first thing that's easy to find? Your D value. So find your D value. On 6. Sorry, did I say 5B? Yeah, number 6. What's your D value? Okay, you're close.
2.25.
What did you get?
2.25.
All right, so let me show you how to do this. Campbell, you don't agree with him, do you? What'd you get?
Where's the?
Negative 1.8.
Okay, so On and Campbell agree. So here's what I do. What's my maximum value that it goes up to?
0.4.
What is it?
0.4.
0.4, right? And then it goes down to
-4.
-4. Correct? How far apart are they?
-3.6.
-3.6? Yeah? Yes or no?
No.
What is it?
1.4.
It's 4.4, right?
Oh, yeah.
There's 0.4.
So it's 2.2.
Yeah. But, just a second, okay? Don't make any... Okay? What is the distance here? It's 0.4 to here, right? And then another -4 down here. Or 4. Distance, positive, right? So that's 4.4. What's halfway in between 4.4? 2.2. So I can either take 2.2 and move it up to here, or 2.2 down to here. What is my D value then?
Negative 1.8.
I made that confusing for everybody, right? I'm just going to take a look and show you.
It just doesn't look like 1.8, you know?
No.
Because the spacing is
graph is-
5.4.
It's just weird numbers.
Yeah.
1.8 would make it like,
Okay? Yeah. Visually it doesn't look right, does it? But we have to trust that these markings are right. So from here to here is 4.4. Right? That's the distance between the two. So then 2.2 is the halfway point. So that is then what? That's this. Right? Is that not my A value? Okay? So my graph moves down to here. Here's my midline right there, right? Midline is right here. Okay. Any questions? Because we didn't all get that right. Do you understand what we did there?
I thought
Okay.
the A would stretch it.
So how do
It
we,
did, 2.2.
but how do we get that from the midline?
The distance from here to here is 2.2.
Okay.
The distance from here to here is 2.2. Your midline's halfway in between, right?
Oh.
So your amplitude is 2.2. And then if I take 2.2 away from here, I'm going to get to negative 1.8. Take another negative 2.2 away, I get to negative 4. Okay, my B value. So we struggled with that a little bit. What's my B value? Does anybody want to guess?
32.
What do you think it is?
32.
Okay, so let's do this then. B is equal to 2 pi over my period. What's my period? 1 pi?
Yeah. Or,
3 pi over 3.
Yeah.
Okay. How are you guys finding it?
negative 0.8 is the, you go, just where it goes to that point again, it's flat.
Okay. Let's do it. You're right. That's how you're supposed to do it. Okay? But when the domain, the pi values, when they don't match well with the y values, okay? Because we can't really tell where negative 1.8 is very easily, okay? Let's humor me for now, use the bottom of the 2, okay? So what's the first low point on the positive? 2 pi over 3. What's the next low point? And when I subtract them, what do I get? Which is exactly right. Okay, so the reason I'm showing you that, all right, is that when the scales don't work so nicely, it's sometimes easier to use your peaks and your valleys. Okay, but you were absolutely right. You nailed it. Okay, so now, take these away. What's my B value? 2. Okay, so far so good? What do you want to do first, sine or cos? Cos? I like cos. I like cos way better because it's always the peaks. And I can easily tell where the peaks are usually. Alright, so y equals 2.2 cos 2 x minus blank minus 1.8. Where is the first peak located at?
Pi over 16.
Pi over what?
16. 6.
6, I think, isn't it?
Yeah.
It's halfway between 0 and pi over 3.
You said 16 is 8.
Oh, you thought that was 8? Oh, I see. Yeah, that makes sense. Okay, so what is this value right here? Pi over 6. Okay, you know how I get that? Yeah?
Yeah.
Okay. Yes, Jeffrey?
Wait, why did you get pi over 6? Is it like, so you go from, I don't get that part. Great.
The first peak value is supposed to be on 0, but it's moved over this far. So what's that measurement? Pi over 6. Okay. Each dash is pi over 6. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. Okay? All right. How are we doing? Let's do one sine one, then I'm done for today. going to give me a sine one.
That's pi over 12.
Oh, that's good. That's good. Yeah. You're thinking going back pi over 12 to the left there?
Yeah.
We're guessing a bit, but yeah.
That's,
Yeah. No, that's pretty good. I'd say you're probably right. Okay. The sine one's not easy because it's not on the pi over 6s or the pi over 3s. Doesn't matter which one you look at, it's not, the midline point doesn't cross over on those. So that's right. You would take a half of pi over 6 and you would get pi over 12. Alright, so the sine one is not that easy for this graph. But again, if you're unsure of yourself on a test, put both of those into the calculator, and if they're not exactly the same, then you know you have one wrong. Alright? They will give you the exact same graph if you graph them, if you have the right equations.
so will there be questions on the test like this where it's a cosine and we have to kind of guess on the sign?
No. You'll know, it'll be precise. Like it'll be more like 5.
No.
Right? It'll be like 5. I'm not trying to trick you. Okay? Yes, Jeffrey.
So, I'm so confused on like finding b. And it's like 2 pi over the period, and now you got like just pi
Okay.
at the bottom.
So Jeffrey, your first peak value is at, your first crest value, your lowest, your bottom, your trough, okay? The first minimum value is at what?
4. Or on the x.
On x.
Okay.
Is your period not your x?
Yeah.
So then on x.
2 pi over 3.
Where does the next one occur, Jeffrey?
5 pi over 3.
So the distance between them is how is your period.
Oh, okay, that's right. Okay. Let's see what you're saying.
Okay? Jeffrey?
Yeah.
Does that answer all your questions? Okay. You guys okay? Alright. What I'll do right now, we are losing a day tomorrow. So I am going to show you the tan graph. And then that way it's not new to us on Thursday. Now, we have talked a little bit about tan. And how do I find tan? On the unit circle, how do I find tan?
Sine over cos.
Sine over cos, right? So what we found out, what two quadrants were tan positive in?
1 and 3.
1 and 3, and they were negative in 2 and 4. So exactly how far apart were they in degrees?
180.
180 degrees, or 1 pi. We all follow that so far? Okay, good. Your tan graph. I'm just going to start on the axes. So at 0. Okay, let me just do this for you. 1 and 0. Agreed? This guy is root 2 over 2 and root 2 over 2. This is 0 and 1. This guy is negative root 2 over 2 and root 2 over 2. And this point is negative 1 and 0. Alright. Okay. So, the tan graph works differently than sine and cos. First reason it works differently is because your period is pi. It repeats itself every 180 degrees. Okay? The second thing that happens is you're going to have a value that does not exist. Because when you're taking sine over cos, you're going to end up with a value that doesn't exist. So we're going to look at that. So here's how your tan graph works. At 0 degrees, right here. Take your sine over your cos. Your y over your x. 0 over 1 is 0. Okay? Add pi over 4. Root 2 over 2 and root 2 over 2 is what? 1. Add pi over 2. So up here, so far I've done this dot, and now this one. What is 1 over 0? It's undefined. So I draw an asymptote right there. Okay, so far? At 3 pi over 4, so 3 pi over 4, right here, what is your tan value? What is it? Negative 1. Goes down here. At pi, what is your tan value now? 0. Right here. Your tan graph looks like this. Like that. Yes. Okay? And again, it's all because of these coordinates. So if I'm going down here, where's my next tan value? So this is negative root 2 over 2 and negative root 2 over 2. It's plus 1. Takes me back to right here. Down here, I have negative 1 over 0, which is undefined. Over here, be negative 1 again. So it'd start there again. So it just keeps repeating itself the same way. So your period for this graph is pi. All right? Your range for this graph and your domain are now different. So this is what I'm going to quickly show you. Your domain for sine and cos are x is an element of all reals, correct? All right? Now, it's x is an element, all reals, but x cannot equal, so 1 pi over 2, 3 pi over 2, 5 pi over 2, so you nailed it. What is it?
2k plus 1.
2k plus 1 pi over 2, where k is an integer. Okay, so we did this yesterday on our zeros. This represents what? 2k plus 1 means that it's what? Odd pi over 2's. That's where all my undefined values are going to be at odd pi over 2's. So again, that's new notation for you. All right? K is an integer.
So it goes x cannot equal?
X cannot equal
Okay.
any of the odd values of pi over 2.
Yep.
So that's 1 pi over 2, 3 pi over 2, 5 pi over 2 would be the next one. And so that's your domain. What's your range for this? That's right. It goes forever, up and down. Okay? So we'll do more questions on tan on Thursday. I need you to just kind of focus on 5.1 and 5.2 today and get through that. Okay? Were there any questions from yesterday other than that question 5? Are we pretty good with transformations then? We've done enough of them? Okay. Okay.